In this section, we're going to talk about continuity. So what does it mean for a function to be continuous? So the word continuous, if something is continuous, it just means it's unbroken or uninterrupted. And so a continuous function is easy to recognize, I feel, if you see it graphed, because you can draw the graph of the function with one continuous stroke without lifting your pencil. Now, when you see the definition of continuity in mathematical terms, sometimes it looks a little more complicated than it really is. But essentially, it just means that you can draw the graph with one continuous stroke. Now, a function is continuous at a point, a, if the limit as x approaches a is equal to f of a. All right, so that's pretty simple. And there's a checklist here for determining whether a function is continuous. All right, so first of all, f of a has to be defined. The limit as x approaches a has to exist, which means that the limit as x approaches a from the left or the right has to be the same, and it has to be a finite number. And then the third criteria in the checklist is that the limit as x approaches a of f of x has to be equal to the value of the function at that point. All right? All right, so in the first example, we're going to take a look at the graphs of some functions and determine whether they are continuous at a given point, in this case x equals 2. All right, so first of all, let's look at a, and the first thing we're asked is what's the limit as x approaches 2 from the left of f of x. Okay, so we have a graph of f of x. If we approach from the left, it looks like the value is approaching 4. If we approach from the right, okay, it looks like it's also approaching 4, which means that the limit, right, the left and right limits are the same, so the limit as x approaches 2 goes to 4. Now it's also defined, this function is defined at 4, or sorry, at x equals 2, and the value is 4. So is this function continuous at 2? Yes. Yes, this function is continuous at 2. It meets all the criteria for continuity. All right, let's look at the next one. All right, so if we approach 2, x equals 2, from the left, it looks like we're going to 4. And also from the right, the value is going to 4. So the limit is equal to 4, right? But g of 2, now it looks like there's a hole at 2, right? Because it's an open circle. So the value of the function at 2 does not exist, all right? So is this function continuous at 2? No, it's not. It's not continuous at 2 because we need the value of the limit as x approaches 2 to be equal to the value of the function at 2, right? So, and g of 2 is undefined. That's another, so it doesn't fit a couple of different criteria in the checklist. All right, let's look at this one, h of x. Again, we're looking at the limit as x approaches 2. So here, if we approach from the left, it looks like it's going to 4. If we approach 2 from the right, it looks like the value of the function is going to 1. So that means that the limit doesn't exist, right? Now, the value of h of 2, because we have a closed circle at 2 comma 1, the value of h of 2 is 1. So the value of h of 2 exists, but the limit doesn't exist. So in this example, this h of x function is not continuous. It's not continuous at 2 because the limit doesn't exist. All right, I'll meet you in the next example.